Humanity has always looked up, wondering what lies beyond the stars. For millennia, the night sky has inspired curiosity, awe, and a deep desire to understand our place in the universe. For centuries, our vision was limited, until the telescope brought the heavens closer, revealing new worlds and moons. Suddenly, the universe was no longer a distant mystery, but a place we could begin to explore, one discovery at a time. We built ever larger telescopes, even launching them into space to escape Earth's blurry atmosphere. Each new instrument opened a wider window, letting us see farther and with greater clarity than ever before. The Hubble Space Telescope transformed our view, capturing breathtaking images and revealing the universe's vastness. But we knew there was more, hidden in the universe's oldest light, secrets waiting to be uncovered. To see the first moments after the Big Bang, we needed a new kind of eye. The James Webb Space Telescope, designed to peer deeper into space and further back in time than ever before. Launched in 2021, JWST is the most powerful space observatory ever built, with a golden mirror over 6 meters wide. Its engineering is a marvel, representing decades of collaboration and innovation. It's designed to capture faint ancient infrared light, heat radiation stretched by the expanding universe. This allows JWST to see objects invisible to other telescopes, including the earliest galaxies and stars. JWST had to unfold itself 1,000,000 miles from Earth, shielded from the sun by a 5-layer sun shield. This delicate process was like origami in space, ensuring the telescope stayed cool and protected. Its extreme cold and sensitivity allow it to detect the faintest signals, like the heat of a bumblebee on the moon. Every component must work in perfect harmony to capture the universe's most elusive whispers. With this new eye, we set out to answer the biggest questions. Questions that have puzzled astronomers for generations, and sparked the imagination of dreamers everywhere. How did the first stars and galaxies form? How do galaxies grow and evolve over billions of years? Where are new stars and planets born? What cosmic processes shape the birthplaces of solar systems like our own? And could there be life elsewhere? Are there other worlds with the right conditions for life to flourish? The mission: rewrite the astronomy textbooks and reveal the next chapter of our cosmic story. Every discovery has the potential to reshape what we know about the universe and our place within it, but no one was prepared for just how strange and wonderful that story would be. The universe, it turns out, is even more surprising than we ever imagined. JWST is not just a telescope, it's a time machine peering deeper than ever before. It lets us look back billions of years to the very dawn of stars and galaxies. It's our chance to witness the universe's dawn, to see the building blocks of life, and to search for our place in the cosmos. With every image, we come closer to understanding the origins of everything we know. The journey had begun, and the universe was about to surprise us all. Each new discovery promises to deepen the mystery and expand our sense of wonder. With JWST, we were ready to see the cosmos as never before. The possibilities seemed endless, and the adventure was only just beginning. The first images would change everything, opening a new era of discovery and wonder for all of humanity. Before JWST, our view of the early universe was like a faded photograph, hints of structure, but little detail. We could only guess at what truly lay beyond, peering through a fog of cosmic history that blurred the outlines of creation itself. We expected to see a slow, gentle emergence of small, faint galaxies after the Big Bang, gradually lighting up the darkness as the universe expanded and cooled. Hubble's deepest images seemed to confirm this, tiny reddish smudges, just as our models predicted. These faint glimmers were thought to be the universe's first attempts at building galaxies, fragile and tentative. JWST was supposed to sharpen this picture, revealing the first galaxies in greater detail, and perhaps showing us the very first sparks of starlight. But when JWST opened its golden eye, astronomers were stunned. The data pouring in was unlike anything they had anticipated. The early universe wasn't a quiet nursery, it was a bustling metropolis crowded with galaxies and activity. JWST's first deep-field images revealed galaxies that were too big, too bright, and too well-formed for their age. These cosmic giants seemed to defy the rules we thought governed the early cosmos. It was like finding a fully grown tree where only a sapling should exist, a mystery that challenged everything we thought we knew. Some early galaxies rivaled the Milky Way in size, blazing with young stars and burning with unexpected intensity. The universe, it seemed, was in a hurry, skipping the slow buildup we expected, racing ahead to form complex structures in record time. Our models were shattered. The textbooks would need rewriting. The rules of cosmic evolution were suddenly up for debate. The cosmic dawn was not a gentle sunrise, but a fireworks display. Brilliant, chaotic, and full of surprises. JWST had revealed a universe far more dynamic and surprising than we ever imagined, forcing us to rethink our place in the cosmos. The story of our origins was about to be rewritten, with new chapters waiting to be discovered. The cosmos was full of unexpected wonders, and with JWST, we had only just begun to uncover its secrets. The discovery of these mature galaxies so soon after the Big Bang shocked astronomers. According to our models, there simply wasn't enough time for such massive, complex structures to form. These galaxies were not only big, they were chemically mature, containing elements forged in multiple generations of stars. This forced us to rethink everything. Did the first stars form faster? Did black holes help galaxies grow? Or is there new physics at play? Understanding how these galaxies formed is key to understanding our own origins. The rapid appearance of heavy elements means the ingredients for life may have existed much earlier than we thought. The universe set the stage for life far sooner than we ever imagined. As if giant galaxies weren't enough, JWST found monsters lurking in the early universe, supermassive black holes. These behemoths, millions or billions of times the sun's mass, shouldn't exist so soon after the Big Bang. In 2024, JWST observed two supermassive black holes merging just 740 million years after the universe began. Traditional models can't explain how they grew so fast. One theory, enormous clouds of gas collapsed directly into massive black holes, skipping the star phase. JWST found the first hints of such objects, possibly solving the cosmic chicken and egg problem. These black holes weren't just bystanders, they shaped their galaxies, triggering starbursts or shutting down star formation. They were architects of the early universe, not just its monsters. The cosmic dawn was ruled by giants. JWST's mission goes far beyond peering into ancient galaxies. It's also on a quest to find life on planets orbiting distant stars, searching for worlds that might resemble our own. These exoplanets, now counted in the thousands, come in all shapes and sizes. But the real challenge isn't just finding them, it's studying their atmospheres for the faintest hints of life. JWST uses a clever trick. When a planet passes in front of its star, some of the starlight filters through its atmosphere, imprinting a unique chemical fingerprint that scientists can decode. By analyzing this spectrum, astronomers can detect water vapor, carbon dioxide, methane, gases that, on Earth, are closely linked to life. Each molecule leaves a telltale sign in the light. One especially intriguing target is K218b, a sub-Neptune planet orbiting in its star's habitable zone. Here, JWST searches for biosignatures like dimethyl sulfide, a gas produced by life on Earth but rarely by non-living processes. The search is painstaking and slow, signals are incredibly faint, and every possible non-biological explanation must be carefully ruled out before any claim of life can be made. We're not looking for aliens waving at us, but for subtle chemical imbalances. Tiny clues that could reveal the breath of a distant biosphere, hidden in the haze of an alien world. Each new observation, each new data point brings us a step closer to answering one of humanity's oldest questions. Are we alone in the universe? Even a hint of life, just a whisper in the data, would be a monumental discovery, reshaping our understanding of our place in the cosmos. JWST is gathering the data that could one day change everything we know about life in the universe. The search for another pale blue dot, a world like our own, is truly underway, and the possibilities are endless. The answers to our biggest questions may be closer than we think, waiting to be discovered in the light of a distant star. The cosmos is full of possibilities, and the hunt for another Earth has only just begun. Amidst the flood of discoveries, JWST found something stranger still, a pattern in the early universe. In a deep survey, astronomers noticed a dozen bright galaxies arranged in a vast sweeping arc, a cosmic eyebrow. The symmetry and orientation were uncanny, as if the universe itself was watching us. Of course, it wasn't a literal eye, but the structure demanded explanation. Such a smooth, ordered arc is statistically unlikely in the chaotic early cosmos. Was it a trick of perspective or a real connected structure? The discovery sparked debate and excitement. Was this a cosmic coincidence or a sign of new physics? The universe had delivered another mystery. Scientists set out to solve the mystery of the cosmic eyebrow. Was it just pareidolia, a pattern our minds imposed on random data? Teams ran simulations, comparing the arc to thousands of possible universes. The result? Such a structure was an extreme outlier, unlikely to be random. The galaxies really were part of a genuine large-scale structure. With coincidence ruled out, attention turned to physical explanations. One leading idea: baryon acoustic oscillations, ancient sound waves frozen into the cosmos, leaving behind spherical shells of galaxies. The arc could be a segment of one such shell, a fossil of the universe's first roar. The eye wasn't watching us. It was an echo from the dawn of time, a cosmic mystery, elegantly explained. So, what does all this mean for the question, are we alone? JWST hasn't found alien civilizations or cosmic superstructures, but it's changed the context, showing the universe is more hospitable to life and much earlier than we thought. The building blocks of life were abundant soon after the Big Bang. The window for life to arise is far wider than we imagined. JWST's discoveries also reveal cracks in our cosmological model, hints of new physics, perhaps tied to dark matter or dark energy. Every mystery opens new possibilities. The universe is stranger than we can imagine, and that makes life elsewhere more plausible. JWST has replaced old certainties with deeper questions. The search for life is now grander, the timeline longer, and our sense of wonder deeper. We are just beginning to listen to the cosmos. The James Webb Space Telescope marks a turning point in our understanding of the universe. We are explorers, glimpsing the shores of a vast new continent. The discoveries of giant galaxies, monstrous black holes, and strange structures are just the beginning. JWST will continue to probe deeper, searching for the first galaxies and signs of life. Each observation could change our world. The universe doesn't revolve around us, it challenges our assumptions. The scientific method thrives on mystery and surprise. JWST's puzzles are invitations to expand our imagination. Our future is to keep looking, questioning, and exploring. For the first time, we are truly watching the cosmos in all its glory. The journey has just begun.